let's look at our problem here. We're talking about the normal distribution. I'm not going to read out the entire question here, so you should pause it probably to read it carefully. Basically, what the question is getting at is how does a change in the standard deviation affect the expected number of defects from a normal distribution? Okay, so let's take a look at our particulars here. Okay, the first thing is, play it out, okay. Okay, Z is a standard normal distribution, and we have our distribution, which I'm going to call X. Now we're going to have to convert our distribution to standard normal, and the way we do that is by subtracting the mean and dividing by the standard deviation. Okay, our first case has a mean of 8 and a standard deviation of 0.1. Okay, let's take a look now at the normal distribution on Desmos. Okay, and this I'll share this link in the comments. And basically, what we care about is the two tails here in red. Okay, so the probability that's defective is this area plus this area. Okay, so one way to do this is to take the area that it is within these boundaries and take 1 minus this area. This will give us the tails, okay? Because the total of the area must be 1 since it's a probability distribution. Okay, and what I'm going to do is actually just calculate one of the tails, because by symmetry these tails are equal. Okay, and I'm basically gonna get this tail at the right side and multiply by 2. Okay, so it's going to be 1 minus the area in the middle, the purple, 1 minus that, okay, and then times 2. Okay, so let's look at the working out here. Okay, so we're looking for, first of all, 1 minus the area in the middle. Okay, we're converting it now to standard normal. Okay, so let's just pause here a bit. Okay, I'm subtracting the mean and dividing by the standard deviation for all three of these pieces, so it's still still stands up to the inequality. This is now standard normal, and I just have to calculate these. These are our z-scores, and as I said before, I'm going to just use the right tail. So that's the final probability. Okay, maybe I should explain also here. Your tables, you have negative values, so you don't have to do, I'm doing it with only positive values. Sometimes you only have tables with positive values. There are different ways to arrive at the answer, and so you should do a little playing around with these things and see if you can find other ways to match this. All right, but this is basically the probability of a defective item. Okay, now if we have 1,000 samples, we want to get the expected number of defective items. I'm using D for defective items. So we just multiply 1,000 times the probability. And they want us to give this in whole numbers, the nearest whole number. So that will be 24. All right. Now we're going to change the standard deviation. Okay, we're going to go through the whole process again. with the new standard deviation. Let's go back now to Desmos and see what happens to the distribution when we change the standard deviation. Okay, so the standard deviation is B, okay? And as the standard deviation goes up, it gets more distributed. The tails are bigger, in other words, okay? So we're actually going from 0.1 to 0.09, okay? So it's more concentrated around the mean. The tails are smaller. Okay, again, we're going to look at 1 minus the area in the middle times 2. 1 minus the area in the middle gives us the two tails. Yeah. Okay, so it's the same process. I'm going to just get this one tail. All right, back to the working out. Okay, so it's 1 minus the area in the middle. That's the two tails. Okay, converting to standard normal there, putting in our particulars there. Okay. Then it's 2 times the area to the left of the right boundary. Okay, so it's 2 times the right tail. And so there's the numbers. Okay, we want the expected number of defects again. So it's 1,000 times the probability of a defect, which is 0.0124. All right, and again, we're going to give it in the nearest whole number, which is 12. So a small decrease in the standard deviation reduced our expected defects from 24 to 12. So cut them in half. All right, so that's a good illustration of how the standard deviation impacts the expected number of defects. And then you're supposed to say, I forget, is it substantial or minimal, the effect? Depends on the definition of those words, but yeah, basically, if it's a small decrease in standard deviation, although how easy it is to get this decrease is not known either. So probably say it's substantial decrease in the defects. Okay, I noticed there's a lot more questions on Wyzant about standard normal. So if you can get your head around this process for this question, you can probably then answer the other questions. Okay, hope it was helpful and good luck.